In this lesson video, we're going to look at lesson 1A.6 for geometry, and we will be talking about midpoints again. Now, we've talked about midpoints before and how we can use those to solve problems using algebraic expressions. Those are expressions with variables and numbers, and how a midpoint is the point that splits a segment into two congruent segments. But today, we're looking at midpoints when we are assigning them to either a number line or the coordinate plane. All right, so a midpoint in terms of a number line or the coordinate plane is going to be a point in the middle of two endpoints, all right? Or along a segment exactly in the middle where we are going to use those two endpoints. And so on a number line, the midpoint value is the average of the coordinates of those endpoints, of the endpoints. So midpoint would equal x1 plus x2 divided by 2. When you calculate the average, you add up how many there are and divide by the number of items that there are. So if I'm just doing the average of two numbers, you add the numbers, divide by 2. So let's try that. So when it says what is the midpoint between -8 and 2, we're going to average those. -8 plus 2 divided by 2. -8 plus 2, you should recognize, is -6. And divide that by 2, and we get -3. Now, you can also think of how this would look on a number line. Okay, so if I've got -8 all the way over here and +2 all the way over here, these are 10 apart. If I take that 10 and I cut it in half, I get 5. So I'm going to go 5 from -8 and 5 backwards from -2, and it gets me to the same point. If I did -8 plus 5, it puts me at -3. The same thing with +2 minus 5 puts me at -3. So there's another way we could look at that answer graphically. If this top way made sense, that's all you need to be able to do. So on this next one, what is the midpoint between -2 and 19? I'm actually going to just use that calculation method, adding them up, -2 plus 19 over 2, and doing the problem that way. And here's why. When I do -2 plus 19, that is a +17. When I divide that by 2, I get a decimal. Decimals are a little bit harder to see on a number line. So I'm just going to write my answer as 8.5, because 17 divided by 2 is 8.5, 8.5. And so let's move on to the next portion of our notes. As we look at midpoints of coordinates in the coordinate plane, we actually have a formula we're going to use. Now, when I just had an x-axis, just one number line, we can think of that always as just like our x-axis, it was the average of those x coordinates. But in the coordinate plane, we also have x and y values. So if I've got two numbers, like in the example down here, where they both have an x and a y, remember we have an x1 and a y1, and an x2 and a y2 like we did for our distance lesson. Well, for midpoints then, I'm simply taking the average of each of those. So you still have your x1 plus x2 divided by 2 to get your new x coordinate of the midpoint. But to find the y coordinate of the midpoint, you add the y values and divide by 2, because you're taking the average of the x's and the average of the y's. So I want you to watch this example. You can copy down as we go, but I'm going to give you a chance to try one on your own on number 2. For number 1, to find the midpoint, we are going to add the x's. x1 is -3, x2 is 1, and we divide by 2. Remember that for our midpoint, since we're taking the average, we are adding. For distance, you subtracted, but for the midpoint, the average, you add. All right, and then I'm going to go ahead and set up the y values also. 4 is my x, or y1, sorry, y1, and 8 is my y2, so 4 plus 8, and divide that by 2. And then I just simplify to find the midpoint m, okay? And I kind of skipped over the written directions here, so let's look at that real quick. Given that m is the midpoint of segment AB, find the missing coordinate. Well, this time we're missing the coordinate m. I give you A, I give you B, that means we need m. So that's what we're trying to find. Sorry if I overshot that. And then it says we're going to graph these 3 points to verify the accuracy of your answer. And so we're actually going to do this a little bit differently when it comes to graphing. So let's go back and finish this. -3 plus 1 is -2. We still have to divide by 2, but I'm going to do the y values next. 4 plus 8 is 12. We're going to divide that by 2. So when I simplify all this down, -2 over 2 is -1, and positive 12 over 2 is 6. Now, I could actually graph these on the coordinate plane, but I noticed that I didn't give you a graph. So here's what I'm going to do. I'm going to draw a segment number line for the x's and a segment number line for the y's. And these are not drawn to scale. This is not actually graphing on the coordinate plane, but we're going to test this out and I'll show you that. We're treating this like a number line. So the coordinates of A for the x values is at -3, 4. There's -3, there's positive 4. And the coordinates of the midpoint m, right in the middle, should be -1, according to my work. Well, -3 and -1, I'm sorry, catch my mistake? Got going too fast. That other x value is not 4, it is 1. That works out a little bit better. So that my midpoint -1, as I was going to say, -3 is just 2 away from -1 on a number line, and -1 is just 2 away from 1 on the number line on that side. Think if you were counting a number line. 0 would be here, -1, -2, -3, there's 1. So you can use that counting method. We can do the same thing for the y values. We start over here at 4 and go all the way to 8. The middle point should be 6. Well, 4 and 6 are 2 away. There's 5, 4, 5, 6. 6 and 8 are 2 away, 6, 7, 8. So again, it works out that the x's are exactly in the middle, the y's are exactly in the middle, and we can verify that that is the midpoint. You're not going to have to use that number line method on every problem, but on some problems, the number line method is actually easier than the calculation method. So here's what I want you to do. I want you to try number 2 on your own. Just doing the formula part. Just use this to calculate the midpoint. If you need more time, pause the video. Otherwise, this is what you should get. Since the x coordinates are 2 and 7, when I add them up and divide by 2, that gives me 9 divided by 2, which is 4.5. And then the y values are -5 and 0, so I'm going to add -5 plus 0, which is -5. -5 divided by 2 is -2.5. And so there's your midpoint written with decimal values. So let's move on down and try number 3. Now this time, I want you to pay attention to what they're telling you on number 3. On number 3, they give you the midpoint and one endpoint. So it actually helps to see this in terms of a number line. In the original directions, in the examples up here, you're told that M is the midpoint of AB. So this is A, this is B, and this is M. So I'm going to show you a little technique for finding the missing endpoint this time using your number line. Okay? The top of your number line, I'll even highlight it for you. The top are going to be x values. The bottom are going to be y values. This is not a normal graph on the coordinate plane. This is just a way I came up with to organize my work and kind of create a puzzle to find these pieces. So I'm going to use these values on top of that number line and these values on bottom of that number line. So for coordinate M, it has an x value of 2, and coordinate B has an x value of -1. And I'm going to look at those and think of those on a number line and try and figure out how far those are apart. And so since I'm kind of looking for my x value of A, I'm going to kind of use a counting method. So from -1 up to 2, and the numbers don't go in the right order left to right this time, but that's okay. I want you to think about what you would need to do to -1 to count up to 2. Well, we'd be counting up or increasing, so we'd be adding, right? So from -1 to get up to 2, I would add 3. -1 is where we start, so the next number we count is 0, 1, 2. 0, 1, 2, that's counting 3. So I'm going to repeat that pattern to move on to the final endpoint A. I'm also going to add 3. For M to be in the exact middle, it has to be 3 away from both sides. So 2 plus 3 then would be 5. So A has the coordinates of 5. All right? Now we're going to do the same thing for the y values. We're going to follow this pattern of counting. So we're going to fill in our coordinates for M and B this way. B has the y coordinate of 0. M has the y coordinate of -4. Well, this one works out a little easier because I know that 0 and -4 are 4 apart, but I'm going from 0 back to -4, so that's a subtracting 4 going that direction. So I'm going to subtract 4 again. If I tried to add 4, I'd end up back at 0, and that's not right. So if I take -4, I wrote a 5. Let's fix that. If I take -4 and I subtract 4 again, I get to -8. So I know that A has the y coordinate of -8. So that's my answer for coordinates of A. 5, -8. Now to verify that, I could go through and I could plug things into my formula. 2 and -4 should be the averages of the x's and y's of A and B. So if I did 5 plus -1 over 2, okay, 5 plus -1 is 4, 4 over 2 is 2. That's the x coordinate for M. I should get -4 as the average of -8 and 0. -8 plus 0 over 2 is -8 over 2, which is -4. So I go back to those original coordinates for the midpoint, and it works. Okay, so let's try this one again. I know it says for you to try this one, but we're going to do this one together. This time, we are using A and the midpoint M to find B. Okay? And so this time, we're going to draw our picture. I'll kind of put it down in the middle here. Here's A, here's B, M is in the middle. The top row are going to be the x's, the bottom row is going to be the y's. I'm kind of making a little chart here. And so the A point has the x value of 2 and the y value of 4. So I'm just making an organizational little chart. The M coordinate has an x value of 0 and a y value of -2. So we're going to kind of use a counting method from 2 up to 0, or in this case down to 0. To get from 2 to 0 on the number line, we would have to subtract 2, right? 2 minus 2 is 0. So I'm going to follow the same pattern to get to the other end, 0 minus 2, which would be -2. So there's my x value for point B, -2. Then I do the same thing for the y values on this bottom row. From 4 back to -2, okay, we're subtracting because we're getting smaller. We're going past 0 even to -2, but 4 down to 0, you can even draw out a number line if you want. There's 4. There's 3, 2, 1, 0, -1, -2 back there. To go from 4 back to -2 is a subtraction of 6. So from -2, I'm going to subtract 6 again. -2 minus 6 is -8. So the y value for B is -8. Okay. All right. And the reason I've gone through this trouble to show you things on a number line is because on the next couple problems, 5 and 6, this is what you're going to have to do. There is no real good equation to use because now I'm not finding midpoint values. I'm not using a midpoint. I'm using, in this case, number 5, a point that is 1/3 of the way from x to y. So I am going to still draw this out in a diagram. Okay? We have our segment xy, and I could put this on an actual xy coordinate plane, but I'm not this time. Capital X, capital Y, those just happen to be the letters I'm using to name those points. It has nothing to do with your x's and y's. It's kind of confusing, I know. But the x coordinates, little x's, are going to be on the top, and the y coordinates, little y's, are going to be on the bottom. Point x has the coordinates 3 for the x, -10 for the y. Point y has the coordinates 15 for the x and -8 for the y. And so if I want a point that is 1/3 of the way from x to y, I'm going to split this not in the middle, no, not in the middle. I'm going to split this into thirds, like that. So each of these pieces is about the same distance apart from the next one. So if I split this into thirds, what I'm going to do now is figure out the entire length from point x to point y for the x's. Okay? To find that distance, the easiest way to do that is actually to subtract big minus little. 15 minus 3 is a total distance of 12. So that x distance from the x coordinates is 12 apart. Horizontally, these points would be 12 units apart. So I'm going to take that 12 and split it into thirds. And every one of these will be 12 thirds, or 12 divided by 3. Well, we know what that is. 12 divided by 3 is 4. So each of these is a length of 4 from the other one. So if I want a point that is 1/3 from x to y, means we're going this direction, that is this point. So I take my x value of 3, I add 4 to it, and I get 7. So I know the point for my answer has an x coordinate of 7. Now I'm going to do the same thing for these y values, from -10 back to -8. Those on a number line are only 2 apart. And in fact, to go from -10 to -8, we're going closer to 0, so that is a positive movement, +2. Okay. In fact, you could even do it this way. -8 minus -10 turns it into +10, which equals 2. So I'm going to take that 2 and split it into thirds. Well, this time that leaves me with a fraction. So I'm going to take my -10 and I'm going to add 2/3 to that to get back here. This is tricky. You need to actually think about where -10 is on a number line. -10 is there, and if that's -9, the next unit over, when I add 2/3, this number here is actually -9 and 1/3. So the coordinates for the y value are -9 and 1/3. Okay? And so that is how you find those answers. Let's try one more. Final example. Once again, I'm going to put points x and y at the ends. And this time I want a point that is 3/4 of the way from x to y. Again, we're going this direction. So x has the coordinates 12, -10. So my little x coordinates are going to go on top. So there's my 12. My little y coordinates are going to go on the bottom, -10. And then y has the coordinates -12, +10. Okay, this one actually works out pretty nice for us. Because I'm dealing with 3/4, I'm going to split that segment into 4 equal pieces. Well, that means I can show the midpoint, but each half is going to get split in half as well. And there's a lot of different ways you can look at this, but I'm going to use the same method I just used. So the total distance from +12 back down to -12 would be a -24. You got 12 to go back down to 0, and then another 12 to go back down to -12. So we're actually subtracting 24 to get to negative 12 there. Well, I'm going to take that total length of minus 24 and I'm going to split it into fourths. Negative 24 divided by 4 is negative 6. So each segment here, each fourth of my segment is minus 6, minus 6, minus 6, minus 6. Okay? So if I take 12 and I subtract 6 3 times, it's like I'm doing, I'll write this down here, minus 3 6s. That's like 12 minus 18, which is negative 6. So the x-coordinate of my point that is 3/4 of the way from x to y is negative 6. I'm just moving this up to give myself some room. Okay, we're going to do the same thing with the y values. From negative 10 to positive 10, that is a total length of 20, but we're adding 20 to the y values. Negative 10 plus 10 gets you back to 0. 0 plus 10 gets you up to positive 10. So you're adding a total of 20. So each one of these is like taking a plus 20 divided by 4. Well, that's plus 5. So each one of these is a plus 5. So to find my y value, I'm going to take this negative 10, and it's like I'm adding 3 5s to it, which would be negative 10 plus 15, which is positive 5. So that is how I get the coordinates of negative 6, 5. That would be 3/4 of the way from x to y. And this finishes our examples on how to use midpoint in the coordinate plane and also how to calculate values that are other fractions of the way along a segment from one point to another.